Hello and welcome back to CST 3130. And this lecture I'm going to talk about how we can use code to create our cloud infrastructure. Okay, so far in this course we've created cloud infrastructures using the console, right? We've gone into the GUI, looks a bit like that, right? We've configured the API gateway, linked it up to certain functions. Then we've gone into the kind of console and actually typed in our code in the console to create those functions, yeah? And then when we ran the functions or tested them in different ways, we then went into CloudWatch and then fished out the logs to see what was happening. And then the whole sort of write, test, kind of cycle was sort of entirely executed by sort of clicking on different windows in a GUI. Yeah. But as you may have already started to realize, clicking on GUIs is actually not the best way to create a cloud infrastructures, right? We've got one problem with this, obviously, is if we're just clicking on GUIs, all of the configuration of our infrastructure, databases, gateways, and so on and so forth, is kind of linked to a specific account in the cloud. Yeah. So if your account runs out of credits, for example, and you don't have any way to add credits to that account, then potentially you lose everything. And suppose I create cloud infrastructure, all the rest of it within one account, and I want to move it to a different account, then I've got to do the whole thing again with clicking on the API gateway and typing in the Lambda functions and so on and so forth. So it's a pretty painful way to work, because we can't easily switch between different accounts, and we certainly can't switch between different kind of cloud providers in that way, except by clicking in their particular GUIs and so on and so forth. Yeah. We also, by working in this sort of clicky GUI kind of way, we lose the ability to kind of, we don't have the sort of nice ability where we can kind of copy a cloud infrastructure, keep the existing one, take a copy of it, and then, use that modified copy to do something new with. Yeah, because often when we're working with code, we'll have an idea about maybe you could change something. We don't want to wreck what we got. We want to keep what we got, but then create a copy of it and then develop it in some way to see if that new development's going to be better. Yeah, and if it doesn't work out, we can always go back to the one we copied. Yeah, but if we're just doing this sort of clicking on GUIs thing, that's not going to work. Yeah. We also, have, it's not easy to check and debug the cloud infrastructure. A lot of that's done automatically because we're working within the GUIs, but still it's far from simple. Yeah. And if we're working, suppose we're building a really complex, large cloud infrastructure involving lots of different pieces working together, that's more likely to be the job of a team rather than individual. And then obviously as a team, it's going to be pretty difficult to kind of coordinate what we're doing by kind of clicking on GUIs in different ways. I have to say, all right, Tom, you click on these bits, and right, Jane, you click on those bits. But obviously it's not the best way to work. What we really want to do is use a versioning system such as Git, and then each of us can sort of work independently on the cloud infrastructure, commit our changes, and then we can sort of, use the sort of, run a diff to see who did what, and, how the change has been progressing. We can roll back to earlier versions of the cloud infrastructure and so on and so forth, yeah? So obviously that would be nice. And obviously, if we're just using GUIs, currently as the console and Lambda functions exist at the moment, we can write JavaScript, but we can't write TypeScript. Yeah, and obviously, I really like TypeScript, so I want to be able to build and work with the cloud in TypeScript if possible. Yeah. So obviously, these issues aren't news to anyone who's worked in the cloud, and a lot of people have worked on solutions that help us to solve these problems. So what people have done is they've developed frameworks that allow us to define the infrastructure using code, such as YAML or JavaScript. We can then test and debug that infrastructure locally before deploying it. And then once we've got our infrastructure in a code format of some kind, we can back it up, we can version it, and we can copy and modify it. And we can easily deploy it to different accounts by modifying our AWS credentials. And sorry, just checking some of that. Okay. And these frameworks, the ones I'm going to show you today at least, they all support TypeScript, so we can work in TypeScript, in a very sort of natural way, and work, in the cloud, using TypeScript. And what I'd say before I sort of continue this lecture is, so obviously this lecture is on infrastructure as code, but the way I've taught this course is obviously, clicking on GUIs and all the rest of it. And there's a reason for that, and the reason is that I think it's easier when you're starting to start off by interacting with the graphical in a graphical way and sort of build your API gateway, REST APIs and your WebSockets and all the rest of it, and configure things all using the GUI tools, because that shows you kind of what's out there and how they work and how they interact together. And then once you've got a decent understanding of it, then I think it's then the time to sort of switch over to using code to configure the infrastructure. Because if I'd sort of taught this course in the beginning using YAML templates, it would have been a lot harder to sort of get going with the cloud and understand it, yeah? But now you've kind of, by the end of this course, you should now have enough of an understanding of all the different concepts within AWS that we've covered, obviously. And then it'd be a fairly straightforward matter then to start mapping that back onto YAML, so you can then take a more sort of general view and actually work in this better way, yeah? Okay, so these frameworks also have other advantages. Yeah, they often offer logging and local testing. Yeah, because as you will have experienced already, when you configure your cloud infrastructure, you put in your functions and you set your roles and all the rest of it. Then you have to check and see what's happened, see if it's working or not. And the only way to do that, if you're working in the GUI, is to look at CloudWatch logs, and they're complicated. They've got this kind of weird sort of grouping and they're a little bit laggy. So these cloud infrastructure frameworks often have the ability to test the infrastructure locally, so we don't have to mess around with all the cloud stuff initially. We can just run it locally, and then when we're happy with what's running locally, we can then deploy it to the cloud and test it in the cloud, yeah? And they also let us access the logs without the CloudWatch console, which is, as I said, a bit of a mess, yeah? Another advantage to these infrastructure as code frameworks is they can run some static checks on the infrastructure to check for problems prior to deployment. They're not going to pick up everything, it's only static, and they don't check everything, but it's helpful, yeah? And as I said, we can use TypeScript to write codes. We can also run static type checking on our JavaScript code. And so we can have a nice sort of workflow where we set our IDE up automatically to transpile TypeScript to JavaScript, and then we can then test that locally and then test that in the cloud and view all the logs locally. So we have a nice sort of integrated way of working that's a lot less fiddly than sort of clicking on different windows in a browser. So the sort of within AWS at least, and possibly there are similar things within Google and Azure. I'm not familiar with these frameworks, so I can't comment on that. But within AWS, the sort of the backbone to kind of configuring your cloud is this kind of CloudFormation tool that AWS has produced. So AWS CloudFormation allows you to write YAML or JSON templates that define the cloud resources and the relationships between them and so on. You can then validate that template and then deploy it, and then it's deployed as what's called a stack. So that you can then create your, so this is the sort of the most basic way, if you like, of being able to create your infrastructure by writing code. So we write these YAML templates or the JSON templates, deploy them, and then we create our infrastructure in the cloud that way, yeah? And there's a console on AWS that allows you to deploy stacks, manage stacks, and there's a fairly complicated template designer tool, or we could use the AWS command line interface to manage these CloudFormation stacks. So here's the sort of CloudFormation, and even when you're running a framework like Serverless or SAM, you'll still be able to see what they're essentially doing is creating CloudFormation stacks, so you can see the stacks that are created by these other frameworks within CloudFormation. So we just take a quick look at CloudFormation console. So we just go to CloudFormation. So let's just have a look. I think we can view our stacks here, right? So here's a bunch of stacks. Obviously I've been playing with this a while for a bit. Well, I've been creating all these different lectures, creating this lecture. So you can see here's the different stacks. I think it's one of the more recent ones here, and I think we can view the sort of recent activity on the stack. And I think there's some monitoring tools somewhere, but I'm not quite sure where the monitoring tools are. There's maybe events, yeah. That's like deletes and all the rest of it. I think maybe CloudFormation have to monitor it. So, yeah, and CloudWatch probably monitor it. But anyway, and if you go back to the beginning of CloudFormation, you can see you can create a stack. And so obviously you can upload the template from S3 or from your file system. And they've also given this offered this kind of designer tool that lets us sort of manually sort of drag and drop different resources and then it'll automatically generate the template for you. Yeah? So CloudFormation already exists, but it's a bit clunky and complicated to use. So what people have developed is these kind of frameworks that sit on top of CloudFormation, and they make it sort of easy to build these kind of event-driven cloud architectures without the somewhat laborious process of creating an entire CloudFormation template. Yeah, often they use similar syntax. So at least two of the ones I'm going to show you today are based on YAML, or you can use YAML with. And these frameworks also offer support for testing, logging, and deployment, right? So so we don't just have to create the template, upload it, and view the logs in CloudWatch. We can actually, do some local testing and local viewing of logs prior to deployment. Yeah. And the sort of what they're offering, as well as sort of ease of use, these frameworks, they often enable us to achieve the same results with less code. So this is a slightly overblown example, because it's a slightly artificial example, but it gives you the sense, yeah? So here we've got the AWS CDK, the Cloud Development Kit, which I'll talk about later. It enables you to build a cloud infrastructure using JavaScript. So these are sort of basically these two, a lot of this boilerplate, but these two blobs of code here, defining a hello function, which is a separate bit of code that is the Lambda function, and then that's linking that up to the API gateway here. And so that AWS CDK, when you call the synth function on it, which I'll explain later, will generate the CloudFormation template, and this is the associated CloudFormation template, and this runs for about 380 lines of code. So it's slightly artificial because obviously, probably if you wrote this from scratch, you could write it in a lot less code. But roughly speaking, this is a much simpler and easier way of building that CloudFormation template than writing that template manually from scratch. Yeah. So these are some of the frameworks that exist for building your infrastructure using code. I'm going to cover 3 in this lecture. I'm going to cover Serverless, which is sort of a third-party framework that supports multiple cloud providers. Then we got the AWS Serverless application model, which is quite similar to Serverless, but is specifically built by AWS for using AWS. And then we got the AWS Cloud Development Kit, which instead of using a YAML template, actually uses JavaScript to write code that configures the infrastructure. There's other ones out there which I haven't looked at in any detail, like Terraform and Kubernetes, and no doubt, various other ones as well. So I'm going to start with Serverless, and so with this framework I'm going to go into a little bit of depth, partly because it's nice and easy to use. I think it's a really good place to start with this kind of infrastructure as code approach. I mean, I think if you're going deep into, the AWS ecosystem, you probably use AWS SAM, set it all up properly, and then it will work very nicely. But if you want something that's sort of easy to install and use and works very nicely, then I think Serverless is a really good choice, yeah? So it's a third-party framework. So, in theory, with a click of the mouse, so to speak, we could deploy this to an Azure cloud or a Google cloud, or possibly an IBM cloud. So it's designed to work across multiple cloud providers, but you just create the single sort of framework, single application, whatever, and then you can choose where it's deployed. And if you want to know more about it, they've got pretty good documentation at their website. Yeah. So Serverless is based around YAML files, and then you have this command line interface that lets you test the infrastructure locally, view local and cloud logs, and deploy your infrastructure to the cloud. So I've mentioned YAML several times already, so I think it's probably time I explained it. So YAML is a file type, or definition of a particular file structure. And if you've ever worked with Python, it sort of works in the same kind of way. So instead of using sort of brackets to define sort of the structure of the application, it uses the indentation level. Yeah, so one sort of tab, so to speak, defines one level, and then another tab will define something that's nested inside something that has the first tab. Yeah. And again, it's a bit like JSON in the sense that you have kind of key value pairs. So you have a key pointing to another data structure, and then so that's what's called a dictionary. And then you have a list, which is more like an array, where you've got a number of items that are sort of just one after the other kind of thing. Yeah, so it's probably easier to do this with an example. So this is a sort of YAML file here. So here I have Martin here as the key, pointing to these data structure here, and then Tabitha's another key pointing to another data structure here. And here we've got sort of key values here, the name, just like JSON, yeah. And then here we have a list where the skills, and we're using the dashes here, and dash and space represents like a list. So for those of you who are familiar with JSON, this is sort of JSON equivalent here, so they've got the key values. So you can see all it's doing really is replacing the sort of curly braces with spaces and indentation level, yeah, to say that, so we know here that name is a part of Martin because it's indented. It's like one indentation extra on top of Martin. So here we've got a list of employees, and then the data structure inside them, and then the arrays work the same as these lists in YAML. Yeah, so you have these dashes and spaces which correspond to the array list there. Yeah. Okay, so that's YAML. And so to start with Serverless, we need to install it, and it's just a node module. We can install it globally, just as we do with TypeScript. And then we create a directory or folder, then we go into that folder, and then we can run the command serverless, and then that will let us set up a new application, new serverless application. It'll create all the bits we need, and then we can, edit those bits in order to create the application we actually want. Yeah. So this is what a serverless YAML file. So when we run serverless, it creates this file automatically with a bunch of defaults, and I'll do a demo on this a little bit later. But just to sort of talk you through the sort of key points of the structure. So serverless has its own dashboard. In the context of AWS, that's not terribly useful because there's tons of dashboards you can use on the console anyway. But suppose if we're working across multiple cloud providers, then we might find the dashboard useful because presumably it will bring together all of the different functions that are running within each of the different, say Azure and Google and the rest of it. It'll bring them all together in a single place. Yeah, but it might be helpful anyway. I haven't really dug too deeply into the dashboard, so I can't comment that much on it. Then we specify the provider, the runtime. I'm not sure what Lambda hashing version is, but it seems to be important, so I left it in. And then we got the regions. Obviously, if we're doing API gateway, you deploy an API to a particular stage. So here we've got dev. The region, we're always going to be using US East 1 if we're in educate anyway. And then we can specify functions and the events that will trigger those functions. Yeah. Now the crucial thing to get clear on with serverless is that the function name is specified here. So hello is the name of the function, and then that points to the data structure that sort of specifies where the code for that function is and the conditions under which that function will be called. Yeah. So here, so let's just so hello is the name of the function. Then we got the handler. So this here is the code that's called when the function is executed. Yeah, so in this case, I pointed this to it. This is a file called handler.js. Inside there, we're exporting a hello function. So that's what's being pointed to here. So when you're telling serverless to call a function, you use the name of the function here, not the name of the function here. So I could have called this say hello or something, but then to call the function when it's serverless, I'd use this. Yeah. And then here we have events at the bottom here. Should have put it in red really. These are what's going to cause that function to be triggered. In this case, we're just putting a simple API around it. So when we go to the path say hello, it'll call this hello function here. Yeah. So all this function is doing is just saying hello world, blah blah blah, returning your standard JSON stuff. I'm not sure we're going back to that. Okay, so let's just do a demo to show you how it actually works in practice. Yeah. So this particular function I'm going to demo here. So yeah, I think you can see this reasonably easily. Okay, so I'm trying to type around this microphone. Okay, so where am I at? Okay, I think I need to go to up a couple of directories. Okay, so cd API. Right, so to sort of initialize everything, currently this is an empty folder, right? If we do ls, there's nothing there. So we need to call serverless to actually, so let me just try and move this a little bit. Okay. So serverless, we just call serverless, right? And then what that will do is, do we want to create a new function? And we want a node. We want to call this project test. Call it test2 or something. Okay, we'll enable monitoring. That's the serverless dashboard stuff. And then, that's one I've created already. Right, so that's fine. And then, so that's basically just initialize everything with default values, yeah? So here, if we go back to this, here's our test2. So remember when you're running it, remember to change into the folder that's been created. And then we've basically got two files in here. We have a simple sort of export thing, whatever. So let's just change this so we know that it's, we'll call this CST 3130 lecture. We'll say hello from CST 3130 lecture. So we just changed it a little bit, and we'll put some logging in as well, so we can see the logging functions later. Log test log in CST 3130 function. Yeah, so we've just added a little logging, so you can see the logging, and you can see it's just returning that, so it's pretty easy. And now we come to the serverless YAML file. Yeah. So you'll see that when it's created by default, it creates a whole load of sort of suggestions, which are actually really helpful. Yeah. So in this case, we can see here it's created the handler.hello, the function here, and then in this case, it's just a function, right? It doesn't actually do anything. So what we probably want to do is connect it up to an event. So here we've got an HTTP event. So if we create a path, say hello, for example. Now here's the bit I meant about the handler hello. So just to illustrate, let's change that to say hello here. Hopefully it'll work. I won't mess this up too much. And then we change this export, instead of hello, we do say hello. Yep. just to make it sort of super clear about that. Yep. Okay, so that's okay, so I think that'll do in terms of the moment. I'm going to come back to this example in a little bit. Yeah, so that's how we initialize the function and how we edit our application just to get it started, kind of thing. Yeah, we'll come to deployment and logs in a second. Yeah. So we created our function. We got our new work. We got our YAML file. We got our function, and now we want to obviously test it and then deploy it to the cloud. So as you'll see, I'll show you one deployment at least in this lecture, but it does take a little while. You sort of sit there for a minute or so while it creates the CloudFormation template, uploads the template to S3, and then it unzips it, and so on and so forth. Yeah, all takes a while. Yeah, so if you want your test development cycle to be a little snappier, what you can do is use serverless to invoke the function locally. Yeah, and it shows the logs and whatever's returned from the function. Yeah. So again, remember to get the function name right. So we test it locally, and I'll show you that in a sec. And then once we're happy with it, we can then run serverless deploy, and then it'll do all the stuff about creating the CloudFormation template, uploading the stack, and so on and so forth. Yeah, and gives you the sort of helpful information about how to view the. That's, for example, here we set up a GET request, so it shows you the sort of path that you need to go on to actually see the function running. Yeah, and then when you deploy it, you'll see the function in the console, and you'll see it in the application, actually, in AWS Lambda, and you'll also see the kind of gateway components uploaded as well, yeah, as well as the stack. And then if you want to see the sort of live execution of the function, the sort of logs, the sort of records of that, then you can look on the Lambda dashboard for that, yeah. And the serverless, as I said, got its own dashboard where you can also see, when the function is being executed. Okay, so let's run a little demo, and I might have to flick back on this because I always forget this stuff. So let's first start with running this function locally. Yeah, so we created our function. Yeah, I think I've saved everything. So let's start by doing we need to get in the right directory first, because remember it's creating a subdirectory, test2. So you need to go into that directory first, and then in directory now. So now we can do serverless invoke. I think it's invoke local, and then we specify the function name, which is hello, isn't it? Okay, so we're running it locally. I think that's right. Why is that? Serverless invoke local function hello. Yeah, that should work. Okay. Oh, yeah, there we go. Yeah, so it's worked. Yeah. So if you look here, we've got test login CST 3130 function there. And then we've got whatever is returned by the function there. I don't know why it took quite so long, but never mind. Okay, so supposing we're happy with that, that's all fine. So then we might want to deploy this to the cloud. So this is completely new from scratch. This is not deployed at all at the moment. So now we can do serverless deploy. So obviously I've set up all my credentials so that that's all going to work. Yeah, if your AWS credentials aren't correct, it's not going to work. And I'm running on AWS Educate here, so it does work with AWS Educate. Okay, so now it's doing all its various checking stuff, and I'll see if there's any interesting insights I can provide while we're waiting for that to deploy. Yeah, so I think I'll come back to that because it does take a minute or two to do, and rather than just sort of sitting around staring at it, we'll come back. Yeah, and we'll discuss logs briefly. Yeah, okay, so serverless is nice because it can pull the logs of your application to your local machine, which obviously makes it much easier to develop. Yeah. So when we're just running it locally, as you saw, if we just do serverless invoke local with the function, you'll see the console output, when we're running it locally. But we can also see the logs when it's invoked in the cloud. Yeah. So we do serverless invoke. If we're calling the function in the cloud instead of locally, we can follow that by the -- log argument, and then we can actually see the logs of the function as it's invoked rather than just the output of the function. Yeah. And it's also got the nice feature that we can also tail the logs of the function. So if something else calls the function, we'll be able to see the logs within the serverless framework whenever it's invoked. Yeah. So I think I've got a. Oh yeah. So finally, let's just see. I think how we're doing with the. No, it's still uploading to the cloud. So obviously, if you're doing, the local testing is pretty useful. So let's just cover a couple more things, and we'll come back to that example. If you want to remove the service, for example, you finished with it, you don't want to pay the money for the storage of that service or whatever, we can call serverless remove. Yeah. So as I'll explain in a little bit, we can use serverless to create things like DynamoDB tables or S3 buckets, And serverless removal will remove those things, but only if they're empty. Yeah? It's sort of like a safety feature, right? So if you've got anything in your table or your bucket, serverless removal will fail, and then it probably won't work even when you've deleted everything from it. Yeah, and then you might need to manually delete the CloudFormation stack. So I tried this, and it turned out that I had to manually delete my stack rather than using serverless, because I tried and failed to remove it using serverless. Yeah, because it has. So I had a table, it had some data in. I tried to remove it, wouldn't remove it, and then it wouldn't remove it even when the table was empty. So I had to go into CloudFormation and delete the stack manually. Yeah. Okay, so with a bit of luck, I told you it took a time. Yeah, here we go. Yeah, so now it's finished deploying everything to the cloud. So now we've got the we can actually go and see the endpoint itself there. So if we go in here, so if you remember the function, we've got hello from CST lecture. Actually, as it happened, I should have deleted this really. The default one is also echoing the actual event itself, yeah, which we didn't particularly need, but there it is, yeah. And then also, so that's created that, it's very nice. And also we have the dashboard here, so we can go and see the dashboard. So this is the serverless dashboard, and I think I called it test 2, didn't I? Yeah, that's it. And then so it gives us all these sort of, useful stuff within the serverless framework that lets us sort of view, the calls to the function and so on and so forth, yeah. Okay, so let's just go now into how we can use the logs. So as I said, I've already covered sort of serverless and local with the functions, so we saw the local logging there, yeah. But if we want to, so if we want to call the function in the cloud with the logs, we can do serverless invoke -f hello, and I think it's log. Is it one dash or two dashes? Yeah. So if we want to see, so now what I'm calling the function in the cloud. But I'm going to view the logs of that function as it's called in the cloud, yeah? So we should see both what's returned by the cloud, but also the logging information from the cloud. So you get this sort of weird sort of, blob of stuff. And then here we've got the log here. I think it's, and then we've got, whatever's output by the function is probably appearing somewhere or other. Yeah, there's the actual output, and there's the actual logs there, yeah? And now if I want to, I can also tail the function. So if I just, without invoking it, so if I do serverless, I think it's, I always forget these things, serverless logs -f, so we can tail -f hello -t. So tail means that whenever there's a new log, then it'll print it out there, yeah? So now we're tailing it. Okay, so I'm not actually calling it within serverless. Instead, if I call it sort of manually here from inside the browser, then we should get a few calls to it there. And as you know, CloudFormation is there's a bit of a delay, but we can see here that we're now starting to see the logs of the function as it's called by whatever happens to call it. Yeah, so in this case, it's just my manual refreshing in the browser. So that's pretty nice. Yeah, so we can then sort of set it all up and then log it in serverless, and then we can see what's happening as we actually interact with it, using a GUI or whatever, yeah? Okay, okay, so, and if you needed to manually delete a CloudFormation stack for whatever reason, it's pretty simple. You just select the stack, and then you can select delete there if that's what you want to do. I can't remember what that one is, so I'm not going to just delete it now for no reason, kind of thing. Okay. I didn't want that. Okay. Righty-ho, so that's the sort of basics of serverless, yeah? I hope I've sort of given a little introduction to it there, yeah? Now I'm just going to show you some of the things you can do with it, and I'm going to go into this in more detail with serverless because, I've got more used to it and I find it easier to use, but everything I'm going to show you here, obviously you can do with SAM or with the AWS CDK, yeah? So often we want, to build functions that interact with a database, and really that's no different from anything else, except we have to add appropriate permissions. Otherwise, we won't be able to. Otherwise, the Lambda function, when it's deployed into the cloud, won't be able to access the database. So here's a very simple scan-db function, standard stuff. We're pulling some data from the database and returning it. Here we're calling the function and then returning it in the body of the message. So sort of thing we might do all the time, building a RESTful API, for example. So everything's the same. There's sort of the functions, the handler, the events. Nothing has to change there really. The only thing we have to change is we need to put in some IAM role statements to give this Lambda function permission to be able to access the database. So all we have to do is to have the effect allow action DynamoDB scan, because that's all it's doing, and then we specify the resource that we're giving it permission to perform the scan on. Yeah, so it's pretty straightforward. And then, you know, using these two blobs of code here, so simple, right? We can easily create a, you know, RESTful API that, you know, gives us all the currency data, for example. Yeah. Now, as a sort of, you probably guessed already, judging from the introduction to this lecture, what I really like about this kind of stuff is we can then start using TypeScript to configure our cloud infrastructure and work with our cloud infrastructure. Yeah. So what we can do when we're running serverless and TypeScript is we can write classes, functions, modules, etc. using TypeScript, so we can have all the nice types. Then we set up TSC to transpile automatically, and so then we have a nice workflow where we're just writing TypeScript. Whenever we save it, it's transpiled to JavaScript, and then we can then choose to test it locally, or we can then deploy the transpiled JavaScript to the cloud. Yeah. So here's the same example, but written of the DynamoDB, except here we got using TypeScript instead. And what we can do, which is really nice, is we can import the types from the AWS SDK, right? So there's types specifying the type of a document client, the type of, you know, what's returned when we run a scan from the database example, yeah? So we can import those from the AWS SDK and then use them in our code to specify the types of different things, which could give us some nice static checking, yeah? And then our handler, again, written in TypeScript, probably not a great deal to say about that really. It does the same stuff with the niceness of TypeScript. All of that's being transpiled into JavaScript, and then we just set up our handler in exactly the same way. Nothing has to change here because everything is working in the same way at the level of serverless. All we're doing is just getting the TypeScript automatically transpiled in something that's actually being uploaded by serverless. Yeah. So I'm not going to do the full demo with the deploy, but I'll just show you the sort of the general idea sort of in WebStorm. So this is my sort of TypeScript example. So it's exactly the same. Here we've got this is our TypeScript database class, except without the niceness. So, oh yeah, here we go. Yeah, I'm importing all the types there. Yeah. So I've written it all in object-oriented JavaScript, which is also nice. And then we have our handler. And then in serverless YAML, so obviously whenever I save this, it's being converted into sort of slightly messy JavaScript. I think slightly old version of JavaScript I'm transpiling to here. It doesn't really matter because I never bother reading this stuff, right? All I care about is the TypeScript. So I've got my two TypeScript files, my database and my handler. And then in my serverless thing, I just specify that the handler.cryptoData, get crypto data, this function here, which I'm exporting in a TypeScript way, is then converted to an export in JavaScript way, so that I can then just, you know, create a nice RESTful API that returns all the crypto data. So it works in exactly the same way. Like I said, I'm not going to bother sort of demoing it because it works the same way as the previous one. Yeah. Okay, so just touch on another sort of feature of serverless with resources. So often with our application, we might want things like a bucket that holds certain information. We might want, for example, a database to hold client's data and so on and so forth. So just like we can configure Lambda functions and events that trigger those Lambda functions, we can also create resources in the cloud, as you expect with infrastructure as code. So here, for example, I'm creating an S3 bucket, giving it a name. We can specify the access requirements on that. And I'm pretty sure you can also specify static files that will be uploaded to that bucket automatically. Yeah. And so when we have a bucket like that, and we deploy it, then you can see the bucket appear, you know, in the list of buckets. Yeah. And the same with DynamoDB tables. We can create tables. Obviously, there are going to be clashes if the table exists already. I'm not quite sure what the behavior is then. And we can specify all the keys and the types and all the rest of it, just as you would within the console. Yeah. So if you have an application that depends on a database backend, we can specify that as well. And then if it's a sort of fresh account, it'll just create all the resources it needs, as well as the code it needs that's required to interact with those resources. Yeah. So as I said, the only tricky thing here is if we want to delete the resources, then you have to make sure they're empty or it won't delete them. Yeah. Serverless also works very nicely with WebSockets. So you just wire up the routes in exactly the same way as the console. Then you just get the functions will need the appropriate permissions. For example, if they're working with databases, which are often the case with WebSockets, right? Because you need to be able to put the IDs into a DynamoDB table. And you can switch to logging on off automatically. So when I initially put together a simple example just to test it, I ran into some problems because I wasn't using async functions, and you know, it just I got stuck in a hole, should we say? But I gave it another go today, and once I fixed those minor issues, it works really easily and has very little code really required to actually make it work. Yeah. So within the YAML file, we specify a function exactly the same way. We've got a connect function, disconnect, default, and message. And in this case, the event isn't the HTTP API, it's a WebSocket event. And so you remember when you wire up WebSockets, you have like connect, disconnect, default, and these kinds of things. And then you're linking them here. It's specifying here when you have a connect route event, it'll then call, this is the handler that will handle that event. Yeah, so we've got a disconnect handler, connect handler, and so on and so forth. Yeah, and if we've got events that are not specific to WebSockets that we've set up ourselves using the action, we can specify them, in just the same way. Yeah, just in this case, a send message action. So this is just an example of a connect handler, I've sort of covered that already. So here we're specifying the connect, and then that's the handler. So I'm not going to go through this. This is WebSocket code covered in my WebSocket lecture. I haven't really changed anything, except I've obviously got the advantage here that with the example of WebSockets I gave, a few weeks ago, I had to write everything in JavaScript. Now, because I'm working within serverless, I can write everything with TypeScript. I can have better type handling, and I actually wrote a nice sort of TypeScript class for doing all the WebSocket stuff, for this example. Now, within the YAML file, in addition to specifying the functions and the routes, we can specify the logs. And here we just have 2 lines of YAML. It's best to switch the logging on and off rather than messing around with configuring the stage and the logging and doing all the permissions. 2 lines and it's all done. And then we need to also give permissions to the Lambda functions to interact with the database, things like scan, put item, delete item. And then obviously the resource on which those permissions apply to. Yeah. So that's my sort of lightning tour, should we say, through serverless, which is a very nice framework for doing this kind of infrastructure as a code stuff. Yeah, and so I've gone into a bit of detail on serverless just to show you how these things work. I'm not going to go into the same level of detail with SAM or with the CDK. I'm just going to introduce you to these because with SAM, certainly the syntax is quite similar and the way it works is quite similar. It's just a little bit more fiddly to get the whole debugging stuff working, and I didn't in the end get around to doing that. But I'm just going to give you a taste just because these are some of the other ways in which you can do the same infrastructure code stuff. Yeah. So SAM is AWS's own framework for configuring, testing, and deploying serverless applications. It's called the Serverless Application Model. Yeah, and so it's also based on YAML, and so you can download and install it. If you want to test locally, you need to install Docker. Yeah, and because I've had bad experiences with Docker in the past, I sort of thought, oh well, I'll skip that bit. But there is if I was working a lot with AWS, I would go the trouble of installing and configuring Docker and finding containers with the appropriate bits so that I could run and test the cloud stuff locally. Because it's obviously a nice feature of SAM that you can properly test your cloud infrastructure locally before you deploy it. Because as you saw with serverless, it does take quite a time for it to upload everything to the cloud. So if you want a faster development test cycle, an accurate local testing is really useful. Yeah, I'm not going to show you that here. I'm just going to show you the basics of getting going with SAM and showing you the rough idea behind it. Yeah, so it's a bit like serverless in the sense that we can just type SAM init, and that'll walk us through setting up an application empty folder, and then it'll give us app.js that has the handlers inside it and a template that kind of configures all the cloud resources associated with that. Yeah. Then we can use SAM deploy guided, which lets us enter some sort of default parameters, the parameters we want for the deployment, and then once we've done that once, it'll save everything in this SAM config toml file, which we can then, and then in subsequent deployments we can just use SAM deploy rather than messing around, with the whole guided thing. Yeah, it did crash the first time I used it, but then it works. So just if it does crash, just try it again, and most likely it'll just work. Yeah. So let's just very briefly sort of run you through using SAM. Yeah. So here I've been using this my serverless. So now if I just go into my SAM demo folder. Okay, so let's just see where we are. Okay, CDs. Okay, so I think it's SAM init. All right, so we go quick start template. I think it is. We don't really care. Zip will do, and then we want. I think the first option here is Node. Some kind of vote confidence in Node, right? SAM app will do. If you just press default, it'll take press return, it takes the default in square brackets, yeah? So, you know, it needs to do whatever. We'll go for the hello world example. I think that's it, yeah? So if we go SAM app, yeah, it's created all that stuff, yeah? So here's our SAM app, yeah? And then what we probably do is, I think in my example, in my JavaScript file, I wanted a, oh, sorry, that's the init. I think I should go through no, I didn't go through a demo actually. I did create a demo. Oh, actually, yeah. So that's the, I'm not going to bother doing all this now. So that's how we initialize it. And when you initialize it, you get the template YAML here. Here we've got similar stuff to serverless. We can specify, you know, all the details about the functions and so forth. We can configure, no doubt, I haven't got into it, no doubt we can configure databases and all the rest of it. And then for the sort of simple hello world function, I sort of did one earlier kind of thing. And so here's my SAM demo, which I edited it. So what I did here is I created a folder called hello world, I think it is app. Here's, okay, so app.js here contains the actual code, the Lambda code here. And that's inside hello-world. And then somewhere or other here, oh yeah, app.lambda handler. Okay, so I think hello world, yeah. So that's the sort of location of the code. And then inside there, we've got app lambda handler, which is the name of that there. So it's kind of working the same way as serverless, right? We define everything using this YAML format. And then we specify things like the path and the method and all the rest of it. And then we do SAM deploy guided, I think it is, yeah. I wonder if I could just deploy, probably shouldn't do this live, but I'm going to try anyway. So here I'm in my SAM app. All right, so if I do SAM, what is it? Deploy deploy -- guided. And then it'll do the stuff, you know, the stack name, the region, yeah, and then yeah, whatever. That's okay, yeah. Save arguments configuration file, some configuration file. So as I said, I'm using the defaults in the brackets here. Okay, so then it does this sort of usual stuff. It'll sort of, you know, configure the cloud and all the rest of it, and eventually give us, you know, the URL of the hello world function we just created. Yeah? So it's created the CloudFormation, and then it creates all the stacks and creates a stack with all the resources that we've specified in our YAML file. Yeah. Probably not worth going into all the details there. I think. Oh yeah, well, it's fairly quick actually. Okay, so now we can see if we go to hello, it's created our hello world function in the cloud. Yeah. Okay, so created, deployed. Yeah, and then if we then look at here, we've got the configuration file here. So now when I next deploy it, it can just use those parameters there. It doesn't have to sort of go through the guided thing a second time, yeah? Okay, so I'm not going to laboriously show you how to do exactly the same set of stuff that I've done with serverless, but because it's pretty similar, yeah? You edit the YAML with slightly different conventions for SAM. That lets you create your cloud resources and deploy them. And as I said, you need to install Docker in order to do the local testing and sort the logging out properly, yeah? Final one I'm going to cover, just more for interest and education, should we say, because again, I'm not going to go into big details here, is the AWS Cloud Development Kit, yeah? So the idea here is kind of neat, right? So previously we've been using, you know, YAML or JSON in the case of CloudFormation to define our cloud infrastructure, yeah? So the idea with the CDK is we can use a programming language instead of a sort of data structure file kind of thing, yeah. So we can basically write JavaScript or TypeScript code or code in another programming language to create the cloud infrastructure, yeah. So we install this the AWS CDK. It's just a node module like TypeScript. We can install it globally in the usual way. And we also have to install these construct libraries. And the constructs libraries correspond to different types of cloud infrastructure resource, yeah? So things like Lambdas or API gateway or databases and so on and so forth, yeah? And there's a couple of links there to the complete list of these construct libraries, yeah? So when you've installed both the core, both the CDK, as well as the core AWS CDK and any additional construct libraries you need, then you're kind of ready to actually kind of create your project, yeah? So you just whack in CDK init, same idea, right? Just like serverless, just as AWS SAM, we just initialize our development environment. You could just copy the files in, but it's probably easier just initializing it in this way. So we call CDK init, specify the language, we install the appropriate CDK construct libraries, and we might need a resources folder at the read of the project to hold all Lambda functions. Okay, so let's go for a simple hello world function. Again, I'm not going massively into detail. So we write our TypeScript Lambda function, should be extremely familiar to you by now. So we have our say hello, right? That basically has a bit of logging and returns, hello from AWS CDK. And then this is the unique feature of the CDK. Then we write JavaScript in order to configure our cloud infrastructure. Yeah, and this is sort of neat, right? So we have some boilerplate stuff, just like we have when we're doing handlers in Lambda. There's like some, a certain convention to the thing. So obviously we're using this nice object-oriented kind of extending the CDK stack, and then this is like the name we're giving to our stack. Then we got a constructor with certain predefined things that some of which are obligatory, some are not. We call the superclass with this stuff. And then we put inside this, we don't really have to worry too much about that because it's just generated automatically for us. What we really care about here is the code that defines our own stack that we want to use in our application, yeah? So instead of, that, we put in this, right? And this code here is we're creating a new Lambda function. We can specify things like the runtime, where the code's coming from, and what the handler is. So it's going to look in a folder called resources for a file called handler that's exporting a function called say hello. And then we've also got an API gateway that that has as a handler this hello Lambda function, yeah. And I presume you can specify things like whether it's a get or post. I'm guessing the default is get, and I'm guessing the default is like the root of the application. So we create our stack, pretty simple really, and then we can test it locally using SAM, which I said I'm not going to demo here. And then we can actually see this CloudFormation template that's generated by the CDK using CDK synth, and then we can deploy it in the same way that we deployed all these other ones, yeah? I couldn't see a simple logging solution. I think you probably have to, its connection with SAM will enable you to do some of the sort of logging and debugging stuff, but I might be wrong about that, yeah? And as usual, you can remove the stack, in this case by doing CDK destroy. Okay, so I'm not going to sort of create one from scratch because it takes a while, but I've got a sort of one I've sort of got up and running, and I'll put this example code up for you. Yeah? So here we've got, I created a folder called resources, and inside here I've got my handler written in TypeScript. And then I've got, where have I got it? Where is my, I've forgotten where I put my thing. I think it's in lib. So this is the stack that I was showing you in the code, right? So we've got our sort of demo stack or whatever. Here we're using code and classes to create our infrastructure, which is the sort of unique and nice feature about this, yeah? So here's my sort of, so here I can show you the sort of synth. So here I'm at the root of the application. I just type synth. And what it'll do is it'll generate the CloudFormation template so we can actually see it and have a look at it if we're interested, which probably not. And then obviously we can do the same thing here. We can do CDK deploy. And then that will actually, deploy it all to the cloud. I don't know if it's storing, there must probably a configuration file that's sort of, okay, so actually that's pretty quick. I think the AWS stuff is quicker than the serverless stuff in deploying by the look of it. And then we can see here it's saying hello from AWS CDK. So there's lots of videos, and there's plenty of links in the resources section, sort of if you want to go into more details of the CDK or SAM. And there's example code from the serverless and the basic sort of SAM and CDK application there as well, yeah? Okay, so I've argued kind of at the beginning of this talk that configuring the cloud infrastructure with code has lots of advantages, right? We can do local logging and testing, we can easily deploy to different accounts, we can do backup versioning, we can copy and paste and modify cloud infrastructures, do static checking, we can work in TypeScript, right? It's obviously the way to go, right, if we're going to do professional cloud development, yeah? And for that reason, there's several infrastructure code frameworks already been developed. I'll bet there's a native solution for every single cloud provider, yeah? So just to summarize the different ones I've covered here, so CloudFormation is the sort of backbone of the AWS infrastructure as code approach. It's great for configuring virtual machines, so on. There's this designer tool you can use, but there's better tools if you're building serverless applications. Serverless I like, and I've gone into a bit of detail with serverless because I find it easy to use. It's sort of super easy to work with Node. You don't have to mess around configuring separate Docker containers and all the rest of it. Works across multiple cloud providers. It only gives best effort local testing, but that's probably good enough for most purposes. Then we got the AWS SAM. It's a bit more complicated to install, but it probably gives you better, more accurate local testing prior to deployment because you're kind of working with a copy of your cloud on your local machine. So if I was a professional AWS developer, I'd certainly get AWS SAM installed. At the moment, I'm just sort of dipping into it for illustrative purposes. But if I was actually, spending my life working with AWS, I'd almost certainly work with the AWS SAM. Yeah. Then we got the AWS CDK. So it's obviously nice to create the stack with JavaScript, and there's certain features and sort of type checking and sort of consistency checks we can run by writing code rather than just the templates. I couldn't, because I probably didn't spend enough time on it, I didn't sort of fully get into the space of how we could actually do local testing and logging, but no doubt if you looked into it, you could get all that running. So really, and obviously there's other sort of third-party solutions and for working with clouds as well. Yeah. So I think, just to wrap everything up, I think this infrastructure as code stuff's totally worthwhile once you've got the basics of working with a GUI. And as I said, I kind of like serverless, but there's plenty of other very solid solutions for working with it as well. That's it.